Dong Energy in Denmark awarded Nexans the contract for producing and installing cables for the Horns Rev 2 wind generator farm. The submarine high-voltage export cable was produced by Nexans Norway at the Halden factory. The production involves several processes, starting with the stranding of a copper core, polyethylene insulation process, lead sheath extrusion, and finally the armouring process. The 41-kilometre-long export cable was loaded on board a cable-laying vessel. The 170 kV cable was then shipped to the Horns Rev 2 wind generator offshore field, located 27 kilometres west of Esbjerg in Denmark. The Horns Rev 2 wind generators will produce a total of 210 megawatts, which is equal to the total electricity consumption of 230,000 households. The installation of the export cable was executed in two phases. First, the cable was pulled into the offshore control platform for the Horns Rev 2 field. Then, the cable-laying vessel installed the cable on the seabed towards landing ground just outside Esbjerg. This operation took place in October 2008. Due to seasonal weather conditions, the pull-in operation to shore was postponed to February 2009. Although foggy and harsh conditions, the export cable was pulled to shore within a few hours and eventually terminated to the electrical grid.
The vessels and equipment needed to lay and bury HVDC cable already exist and are used around the world. In this video, we will watch the process and see how the equipment works. The HVDC cable is slowly fed underwater from a ship, which receives a steady flow of information from below the surface of the water. A small camera robot sends a video stream back to the ship to provide details on the seabed. Notice how the ship is able to retain its course even in significant currents. If a major obstacle is encountered, the cable guidance system navigates the best cable path using sonar and cameras. state-of-the-art navigation system employs GPS, sonar, and video to ensure the cable follows the ideal route from the power source to the grid where it's needed. It also gives a detailed record of exactly where the cable has been laid. Once the cable is on the seabed, the cable burying system is deployed. Using an innovative and low-impact system of water jets, it follows the cable path, digging a temporary trench of only a few inches wider than the 6-inch diameter cable and approximately 3 feet deep to protect the cable against external mechanical damage. When an obstacle is sensed, the cable laying is paused until the object is cleared by the water jets. Once the destination is reached, a protective concrete barrier is placed over the cable at the point where it begins to ascend from the water. This actual video footage of underwater cable burying illustrates how the system works and shows how little impact it has on the seabed. Notice how narrow the trench is, and how just inches away from the trench, the seabed sediment remains undisturbed. Within a few days, it would appear as though nothing ever happened.